Hi everyone, I'm Gujuan from Taiwan. This is my pleasure to receive a line invitation to participate in this year linedevday. I am an engineer working in a startup and also a line API expert. Cofacts is a project I co-founded with my friend in my free time. It mainly serves users in Taiwan and is also a folk project in Thailand. Currently the largest and public rumors database in Taiwan. All of the systems are open source, so the code can be found on GitHub. Let's start with misinformation that's very close to our lives. During the COVID-19 period, there were the rumors that the raw materials of tissue paper and masks are the same, so there would be a shortage of the tissue papers. This instance happened in Taiwan last year. It was a rumors made by a salesman. This year, taking advantage of the reappearance of the COVID-19 wave, it began to spread in Taiwan around February 4th, and the government classified the rumors on February 6th. After that, the police received the relevant persons on February 9th. Unfortunately, the same rumors appeared in Japan in March. Such relative rumors are endless, and the user can also believe because of panic. Furthermore, in close messaging app, false messages going viral from one close chat room to another. One may see the same message again and again across a different chat room. Our database shows some rumors have very high survival rate. It is our list of the top 5 rumors with the longest survival rate. So far, they had extended over 2 years. And the other example is about HIV in the canned food in Thailand. It has been proved to be a hoax by the Snopes a long time ago, but however it still appears on Cofacts. It is sent along with an English paragraph. Cofacts linebot is able to catch this occurrence several times through the years. Here each bar means the number of times linebot user react to these rumors within a week. This rumor is beginning circulate many times. The timing seems random. We can expand the timing yet. Most waves shows the same pattern. They appear suddenly and quickly decrease after a week or two. After 1 month or so, we cannot predict its extent until the next wave arrives. Although this post seems integrative, it is a pressure chance we can accurately mention the wave of information currently in the closed messaging platform. And this is why we want to create a linebot to stop the spread of these rumors via IMs like Line. By the power of message forwarding, user unknowingly accelerate the spread. So which is why we hope to alert them before they choose to forward it. This is how it works. Whenever user receive a message and they want to look up for different thoughts, they can just forward the message into the Cofacts linebot. In this chatbot will automatically respond with the contents written by Cofacts editors. If the user is satisfied with the response, they can choose to forward the response back to the original chat room. In this way, all other people in chat rooms can have more information from different perspectives, and hopefully they can use that to determine whether they should keep spreading that original message. Lastly, if user forward the linebot a message that we don't have in database. We will invite them to become the first one in the world that report such message. With users' consent, the message will be published in our open database. And after the message is sent to the database from linebot, the editor can see the message in the Cofacts website. The Cofacts editor can compose replies to each message in the database, so that when the similar messages are sent to the chatbot, it will automatically reply with what editor has put in the database. For each replies, there are 3 steps for editors: choose the option and write down the content and attach the reference. This is a simple flow of Cofacts system. In the center of system, there is a database of user report message, and the crowdsourced reply connect to the message. There are 2 types of user involved. The user in line can search for reply and submit new message via linebot. On the other hand, the Cofacts editor can add the replies and can compose the replies on the Cofacts website. And I will go through the technical used by Cofacts. I will give the overview of the entire architecture and then pick up the 3 main and distinctive parts of architecture. 2 parts are line messaging API and the LIFF related to linebot, and followed by machine learning, which we use to classify messages. Okay, let's go to the overview. This is the whole picture of an entire project. I quickly explain the components. And each component has a GitHub repo, which is all open source. Cofacts DB store all the data sent by line users and the fact-checking replies by editors. We use Elasticsearch as our database, and Elasticsearch is also suitable for text search. We use Elasticsearch to find similar messages and combine the similarity calculation we wrote, then we return the result to the user. And this following is a Cofacts API. This is an API server read by GraphQL to provide data to website, a website for editor to do fact checking, and to linebot for the normal user, and also for the other third-party application, and we will be mentioned later. The URL resolver will do 2 things. The first thing is pass the message for URL, because user will directly send the message with a single URL and a few text. So we retrieve the previous text of the URL and then perform text search. The second thing is that the forwarding message will often be in photos. We use text array OCR to convert image into text and then perform text search. A Cofacts open data is analytics data. It has data from line OA, including the edge distribution of user and the local distribution. There is also the identity open data, which packs the data sent from a linebot and the fact-checking reply made by editor as well. As well, the label data we used for machine learning. This open data are suitable for the data scientists to conduct the research and the analytics and then analyze. Then the line message API and the LIFF are related to linebot. These 2 components in this place, they use the data provided by the Cofacts API. And this is a finite state machine, which is convenient for us to develop linebot. The finite state machine presents is a process of state transition. We can imagine that the process of a user a process of a user interaction with our line bot is a state transition. Also, because the usage of line bot is relatively linear and highly dependent on the previous state, we can use this table to make detailed records. It's convenient for us to develop by ourselves, and also is convenient for open source contributor. Okay, let's look at how this pictures is applied. We simulate a lucky user to find he wants. The user starts from the init underscore INIT. He received a message. He was suspicious for the message, so he forwards the message to Cofacts line bot. Then he came to the state of choosing article. And very lucky, Cofacts line bot found some highly likely message. Then he need to choose one to continue his journey. After user choose the message, he was likely that the editor of Cofacts has verified this message, and there were multiple fact-checking results. So the users must choose the result he wants to read, and this time the state is choosing reply. He must choose a reply before processing. Okay, he chooses the reply, and the Cofacts line bot return the detailed information of these replies. The result is misinformation, and the content and the attached reference. And then Cofacts bot will ask a user for the feedback, and this time he stopped in the state of asking reply feedback. User feedback will be counted in the database. With the feedback, we will know if the fact-checking result is useful or if there any need for improvement. Okay, the user click help for, and this time LIF will pop up. LIF is a key role in here because we need to ask a user for feedback, and he will need to enter the information through line. And this information will be a paragraph. At this time, if our dialogue remained in the line bot, it will be very confusing. So that using LIF can cut through the environment so that user can clearly input his feedback. After writing the feedback, the finance dimension is over. Okay. Next, we look at another lucky users who become the first persons to report the rumors. Similarly, the user forward the message to Cofacts line bot at this time. Cofacts line bot returned some possible message, but he did not find it he wants. So he told the line bot that he couldn't find the message he wanted. So the Cofacts line bot invited the user to become the first one in the world that reports such message. And this time, the state goes to asking article submission. The user is sure to send message into a database at this time. This pops up because the line bot requires the user to tell him more information. We have made two questions to collect the user feedback and also filtering. One is where the user saw this message, and the second is why he thinks this message is misinformation. After user fill the question, we will add the message to the database, and this interaction ends here. We can see the LIF plays a key role in this. It can efficiently improve the process. This is our finance dimension result using LIF. And this time leaf was not available. You can see there were the more nodes and edges in this finite state machine. And this finite state machine is after we use the leaf, which is the finite state machine we mentioned. We use the leaf to deal with the timing when user need to enter information with paragraph. Because such a situation is easily confused with the situation of linebot itself. So when such a situation occurs, we will choose to use leaf to interact with users. The interactions can gradually reduce the state of entire linebot. The advantage of this is that users are not so confused and the developer do not have to handle so many states. So we reduce from the 19 states to 7 states, and the age are also reduced from 31 ages to 13 ages. Let's take a look at how Cofacts handles such issues in linebot. We make a decision and also a trade-off. The problem is the message may vary across time. What if the user forward a message that looks like multiple message in the database, but all of them has some sort of variation? Whose reply should the linebot shows to the user? Previously, we just returned one best match to the user. But when all matches are not good enough, the best matches is not accurate as well. In that case, the user may receive a reply that is not relevant to the message, which confuses the user. We can raise the bar of similarity so that the chatbot only considers message that's almost identical to the user query, but it will return no match more often. But then we cause the user to submit a nearly identical message to the database again and again. In this scenario, user can get the replies, and the editor would also frustrated by the recurrence in the messages. And this is why all matches in the database are not good enough. The linebot will not just list all matches and ask a user to pick one. If the user thinks all of the messages in the database are not what they want, they can submit a new message to the database. These three structures explain that the situation. When users send a message, there may be the three results: M1, M2, and none of the both is M3. Then there will be a fact-checking reply for each message. For example, M1 has R1 and R2, and M2 has R3. In this situation just now, suppose the user wants to choose M1 and then choose R2. If we choose M2 for the user and return R3, and this time the user will get information he didn't want, causing confusion. So we decide to return all the results and let him choose by himself. Okay, let's take a look at the machine learning we used to classify message. On this diagram, you can see that there are multiple models under Cofacts AI. Cofacts AI will responsive for delegating these models, and can easily switch, enable, and disable models. This picture shows that the filter in the Cofacts side used by the editors. It can select a specific category such as politics or healthy. The reason is that that there are many messages that requires editor with spatial background to do fact checking, such as medical messages by doctors. A Cofacts AI will automatically give the labels for this message, and also editor can label by themselves. And you can see some features on the right. First, we have 17 initial categories. We outsourced the 15K messages in the database to an external company for labeling as the ground truth for the machine learning. We can add a new category or disable a category, and the editor can add categories for the message. And there are 2 running models now. We also support any contributor who want to create a model. This is the 17 labels. These 17 labels comes from the classification of rumors we have observed. We use these initial 17 labels to the label and the label data to make our two models, back of world models and the bird model. And this is our statistics for on the database. This is 4 category covers about 17% of the messages, which are health tips, food safety, and URL only, and politics, party, and not included. Both of our models have very good performance. The back of world model has about 81 and 65% in training accuracy and testing accuracy. In addition, it has significant effect on these 4 categories. And the bird model performed better with the 85% and the 71% accuracy, and with the same distribution. Okay, let's talk about how the models is encapsulated. Each of our models has these 4 requirements. The first is must to be a dark image, and must be stateless, independent, and open source. The sequence diagram on the left side describes how models work. First, the AI master will get the message from the database and do pre-processing. After the model registers with the AI master, it gets ID and the API key. It passes these 2 parameters to the Docker and start it. And then the model will continue to get text from AI master and return result until there are no tasks from AI master. There is how single models interactive with AI master. And how does the AI master handle the incoming message? AI master has a cron job that will call the model to process the task every day. First of all, it will pre-process a new messages generated today and call the model through the Docker Compose app. And this time, the model will operate as just mentioned. It will process all the accumulated message at that days, and then turn off. This approach is to concentrate the computing power and save the cost of GPU instance. And at present, the execution times of our 2 models will probably be within an hours for processing the hundreds of messages. Okay, let's go statistic. Last year, This statistic we built in the Google Data Studio, also open source for everyone. Next year, we publish the usage analytics for how users use our linebot. It shows the messages actually begin forward to chatbot. It is available for everyone, and the URL is on the right corner. Previously, knowing what is being circulated in closed message platform is not possible right now. But Cofacts analytics data, we can shed some light on it. We did the research in the 2018 Taiwan election. With the analytics data, we compared the top 25 popular message in 30 days before election days, which is in the middle, and other 30 days ranges before and after that. Here we highlight those read political messages. We can see before and after election months, political messages are not so popular. But during the election months, over half of the popular messages are political. And we look at the search trend across time. We found that non-political messages, which are in the green, have occurred before and after election months. The election has no effect on whether this message occurs or not. On the other hand, the political messages are most likely to occurs during the election months and have few before and after election months. Those messages are created and distributed within the 30 days range before election days. For me, this looks like pretty much like a designed disinformation attack. And we can take a close look at the contents of these political messages. Some of them is over Taiwan same-sex marriage politics, which is unsustainable. However, we found quite a few of them is not targeting any candidate or topic. Instead that the message targets the election process. These messages are craft the breed mistrust of our democracy society. This is the trick because people tend to forward such messages no matter what candidate you support. It is not targeting the center candidates, it is targeting our democracies. So that is our research in the election and the statistics in our database. And then we talk about crowdsourcing and the collaboration. And back to the diagram, there are two components maintained by the third party contributor. And we will welcome and encourage anyone to make use of the open data we provide. In Taiwan, there are two linebots, the Meiyu and the Doctor messages. Let's connect to Cofacts database and provide automatically replies right inside the chat group. Of course, our source code of the linebots, the website, the API server, and the AI models are available at the GitHub for everyone to reuse. And tens of thousands of the messages we have collected from the start of this project is also available for everyone and free for charge. We have devoted the data to the public domain with CC0 license. And our member meeting notes and all design decisions are open as well on the internet. To sum up, the Cofacts is a line bot that searches for replies right inside the chat app. For those who don't want how to Google, Cofacts lowers the entry barrier and empower them to find information on their own. By collecting real-world interactions, hugs, and inviting everyone to become the editor, we hope the Cofacts can facilitate the spreading of the fact-checking reports and helps the users gain information to think independently and finally improve the media literacy of all citizens. And this is the end of my presentation. Thanks for you listening.